My name is Dr. Gasser Abdelal. I'm from Queen's University, Belfast. Today I'm going to present a challenging module I developed last year. It's mainly on space engineering, the space engineering module. So it started with the School of Mechanical and Aerospace Engineering assigned me to develop a new module at our school, School of Mechanical and Aerospace Engineering. So my background, research, academia or industry, it's mainly focusing on multi-physics modeling. So multi-physics modeling means just how the interaction or coupling between different physics, like the structural materials, deformation and stresses, the heat transfer, for example, and, or for example, fluid mechanics, electromagnetics, if you talk about thermoplasm. So for example, fluid structural interaction, if you are modeling, for example, fluid solution in tanks, and you want to simulate the dynamics on the aircraft or dynamics on the tank itself due to fluid solution. Or thermal stress coupling, for example, if you're simulating shot pin process, aircraft wing, or simulating riveting process, or again on aircraft assembly. So in this case, you need to study the coupling between the heat, the temperature, and the stresses and deformations. Fluid thermal structure coupling, for example, if you talk about something similar to lightning strike on aircraft structure, but of course it requires electromagnetic. If you want to simulate the full magneto-hydrodynamic model of a lightning strike on aircraft composite material structure to simulate this deformation. So my idea on this module, I said, okay, I will develop then a simple module, not simple, a module that teaches the students about physics or the multi-physics and how to use MATLAB and ANSYS as a finite element model to teach them about how to do, you just model partial differential equations in MATLAB about structures or heat, electromagnetic or fluid, and how to couple between them to study different problems. But then the school said, no, stop. We have a problem here. We have feedback from the accreditation and the students that they need to develop a module on space science, space engineering. So they said, no, the idea of only multi-physics is not required. We need to teach them about space topics. So I already teaching since 2012 a module on design of cube satellite structures using my book I published with Springer. So just only mechanical design, the same standard modal, harmonic, fatigue, all this kind of stuff, vibration. So I cannot utilize it in the new module. So I decided to move them. Okay, let's then develop a module on space system engineering. In this case, I said, all right, I have two books. The first one on the left is very difficult to find. It's only available in paper. All right, it's like £300 to buy, and there's no digital copy of it. The other one, which is NASA System Engineering Handbook, was very useful and available in PDF. So it was very good for the module. And then I said, okay, I will do coupling between these two principles, the space system engineering and multi-physics. I will not just teach only space system engineering or teach only multi-physics modeling. I will do a coupling between them. So the idea is I have 3 hours each week. The first hour is just theory. She's just discussing the basics of space missions, mission design fundamentals, the different environment impact on space system design or space system subsystems, thermal control, communication power, all this kind of stuff. And it was not just theory, so I used the Mars rover to again illustrate how to apply these principles on the design of the Mars rover itself to make the module interesting, not just guys sitting there hearing just basic theory and getting bored about it. The other 2 hours then of the 3-hour weekly, then I started to teach them MATLAB codes using the Aerospace toolbox, teach them about orbit mechanics, simulation, or interaction between payload subsystem and another subsystem like the thermal or the power, etc. Some also MATLAB codes on that handling, etc. Just MATLAB codes and just an application on the space system engineering principles using MATLAB. So up to now is nothing really new. It's up to now just a standard space system engineering module. The other thing new stuff is this. So from week 4, I started to introduce multi-physics modeling to the module. For example, the mechanical design of rover moving on space terrain in ANSYS, how to model that in ANSYS. So I developed these codes for them myself, and then I gave it to them and asked them to change some of the parameters. Terrain parameters, for example, the space capsule, for example, Earth re-entry, I asked them to make it to Mars re-entry. So the difference is what? Pressure, heat flux, and ambient temperature. That's it. That's how you can change my model from Earth to Mars, for example. All right? And of course, again, thermal mechanical, the first one thermal only, this one thermal and mechanical, and the last one was space debris protection system. Again, it's the NASA design, how to develop a protection system against space debris. Again, just using ANSYS model. So the assignments for them, I decided to make it like group work. I say maximum 2 students for each group, and you have to choose one of these five projects. All right? It will be only a feasibility study, not a full final product. One on structure, one on thermal, one on mission design, one on space debris protection systems. The majority of the students choose project number 4. But some of them really, 1 or 2 choose structure, others choose thermal, etc. So that was the design of this, the assignment element of my module. So what were the challenges? The challenges then. First, the students found the contents difficult. It was too much to teach over 12 weeks. MATLAB, ANSYS, space system engineering, it was too much for them. The students lacked basics of MATLAB and ANSYS. All right, teaching them about multi-physics, so they required a little bit higher than basics even, knowledge of MATLAB and ANSYS. So that's why I will say later what I did for the next year. Of course, many projects were tough, but yet really they worked very hard on them, and the school was amazed really by the project outcome and the project reports submitted for this project, which means the students were engaging. They were suffering, they were complaining as usual, but they were engaged with them. All right. So the other thing, I was trying to teach them how to use AI to write MATLAB codes, and because last year it was the new birth of AI, so it was really complicated to convince them and encourage them to use MATLAB, ChatGPT to write MATLAB codes. You don't need to spend 2 hours writing a MATLAB code. You can write it in 2 minutes. You can debug it in 2 minutes. You don't need to. But anyway, at the end we listened, but it was not easy process. But I think it will be easier next year for them to use AI, because there is now another half of this module called AI and design. So in the second half of the other module, they learn more about ChatGPT, how to use AI to achieve mechanical design principles. So that's it. So to how to update my module for next year, I said, okay, we decided to extend the module to 15 weeks from 12. So the first 3 weeks, I'll be able to introduce students a little bit smoothly in MATLAB and ANSYS and prepare them for the next task, and maybe a little bit of AI also. And I also added 2 class assignments during the 15 weeks, plus the mini projects, just to improve the student engaging with my module. That's it.